Welcome to the Unit 0 Section 3 video on dimensional analysis. Let's start off by talking about units of measurement. The units of measurement are the collection of standard and other units that are used to measure various physical quantities. Okay, so we have all sorts of ways of putting some sort of unit that defines how much of something we have. For example, we talk about centimeters, and of course a meter is longer than a centimeter. We can measure longer distances using those longer measurements, okay? And talking about taking a road trip, you might talk about miles, which is an imperial measurement system. We'll talk about that here in a second. You're going to measure the distance between two cities in miles, but say on a football field, a mile is too long of a measurement. So we use a shorter measurement, and we use yards on a football field. So in the United States, the customary measurement system, or the imperial measurement system, is used for everyday tasks, such as finding the volume of a bottle or the length of a room. However, scientists throughout the world use the metric system of measurement, and many of the countries across the rest of the world actually use the metric system as part of their normal everyday use. So, for example, in your car, if you look at the speedometer, you're going to see miles per hour in the bigger numbers. But then if you look on the smaller side, you're going to see smaller numbers, whereas kilometers per hour. Because if we were to drive a car from the United States to Canada, in Canada, they measure their speed in kilometers per hour because they use the metric system. So let's talk about some of the different types of units here, starting with length. Okay, so for length, we have customary units, which we typically use in the US, and they consist of things like inches, feet, yards, and miles. Across the rest of the world, you have things like millimeters, centimeters, meters, and kilometers. You'll notice that all of these end in the word meter, okay, because there is a order to, say, 100 centimeters make up a meter. You have these measurements relate in units of 10 or by powers of 10. And that's going to be the case for capacity and weight as well. In the United States, in the customary or imperial measurement system, we use things such as fluid ounces, cups, pints, quarts, and gallons. These are terms that you hear a lot around the kitchen when you're trying to bake something, or you also hear the term gallons used when filling up your tank of gas in your car. In the metric system, you have most commonly milliliters and liters. For weight, in the customary or imperial system, we use ounces, pounds, and tons. Okay, you go and weigh yourself, and you can find out how many pounds you weigh. But in the metric system, we use grams or kilograms. Now, for time, that's going to be the same for both, okay? And there, of course, is a big stretch between seconds and millennia and everything in between. You've got seconds and minutes and hours, days, turn into weeks and to months, go into years, go into decades, which is every 10 years. Centuries is 100 years, and a millennia is 1,000 years. So let's talk about the how we can figure out what type of unit should we use. Okay, so we're going to determine the most appropriate unit to measure the following scenarios. So in A, we want the distance between two cities. So we talked about this before. If you want to measure the distance between two cities, you're probably going to do it in miles or kilometers. For the height of a person, you're going to use probably feet, because a person's 5'6". That's 5 feet 6 inches. Or you may use meters if you're looking at the metric system. For the weight of an adult, you're probably going to be talking pounds or in metric kilograms. The time to drive across the United States. Well, you have to think about what type of time scale can you use. To drive across the state may be hours, but to drive across the United States, that's going to take more than one day. So you might want to measure that in days. For the size of a piece of paper, we usually do that in inches or in centimeters, if you're talking metric. The amount of water used to take a shower, probably talking about a few gallons, or in metric, a few liters. The area of a football field, we're going to be talking about square yards or square meters. And then the amount of liquid cough syrup in one dose, you're probably going to do that in fluid ounces or milliliters, or you may even alternatively use the term teaspoon or tablespoon. So now that we're familiar with measurements and units of measurement, let's talk about actually converting measurements, because sometimes you need to know something in a different type of units. Okay, so dimensional analysis is the way that we do this. Dimensional analysis is a way of using units to help solve problems involving measurements. You can use dimensional analysis to convert units by setting up ratios of two equivalent measurements. These ratios are called conversion factors. So here's a list of some of these conversion factors. We have length conversions here, and you have those in your notes. The same table that you see here is in your notes. So for example, in that first row, 1 foot is the same as 12 inches. 1 yard is the same as 3 feet. 1 mile is the same as 1,760 yards, and so on and so forth. Also have capacity conversions here as well. We talked about tablespoons and teaspoons. That is part of capacity, and here's a fairly thorough list of some of your conversions. And you'll notice in these tables that I not only provide conversions within the metric system and within the imperial system, but also from imperial to metric and metric to imperial. You've got a few of those conversion factors as well. We also have weight conversions, how many ounces are in a pound, how many pounds are in a ton, and so forth. And we also have your time conversions, okay? Now, if you need a conversion that is not listed in this table, because this is only a select number of conversion factors, Google is your friend. You can go to Google and get the conversion factor that you need by just simply typing in the search, and typically Google will just give it to you right off and tell you what that conversion factor is without even having to go to a website for it, okay? So, in order to do this successfully, you're going to determine the given unit and the desired unit. You're going to choose the conversion factor whose denominator has the same units as your given value. Then you're going to write the original value next to the conversion factor with a multiplication sign between them. And then you're going to cancel the like units. Then multiply the resulting equation across the top and the bottom. Now, I know this is a lot of kind of word soup, but I think these steps to success will make more sense when you see an example. So let's take a look at a few examples. In example 2, we're going to convert 7.2 meters to feet. Okay, so we start by taking 7.2 meters, and we're going to go ahead and put it over 1. Okay, then we're going to find our conversion factor, and on our tables we can find that 3.281 feet is the same as 1 meter, okay? So we're going to be able to cancel the meters off the top and the bottom, and we multiply our two numbers on the top to give us 23.6, and then our resulting units is feet. And here you'll notice that I'm using the wavy equal sign here. That's because this is an approximate answer. This was rounded to 1 decimal place. For example 3, convert 4.3 pounds to kilograms. So we start with 4.3 pounds, and then we're going to find our conversion factor, which is 2.2 pounds is 1 kilogram. And then we are going to cancel the pounds off the top and the bottom, leaving kilograms on top. And then we'll do 4.3 divided by 2.20, because the 2.20 is on the bottom. And that's going to leave us with 2.0 kilograms. Now, this is a round, okay? Don't just put 2 kilograms if you're told to round to 1 decimal place, because when you do the math, you'll probably find that there are numbers that follow that 0. So this is a rounded answer, 2.0 kilograms. For example 4, convert 5 gallons to pints. So we start with 5 gallons. We find our conversion factor. There's 8 pints in a gallon. Gallons go on bottom, so we can cancel the units off the top and the bottom. 5 times 8 gives us an exact answer of 40 pints. So in this case, 40 pints is exactly 5 gallons. For example 5, converts 15 inches to yards. So we've got 15 inches. We're going to find the conversion factor from inches to yards, or if we don't have that, we can do two conversion factors. So we'll start with inches to feet. There are 12 inches in a foot. Then we're going to convert feet to yards. There are 3 feet in a yard. So from here, you're going to do 15 divided by 12 times 3. Now remember, when doing order of operations, everything in the numerator and everything in the denominator are groups. You could set those as parentheses. So you do the 12 times 3 on the bottom first, and then you do 15 divided by that result, which 12 times 3 is 36. 15 divided by 36 is going to give you 0.4, approximately. And then for example 6, convert 5 meters to feet. So we start off with 5 meters. We're going to convert our meters to yards. 0.914 meters is 1 yard. Then we're going to convert yards to feet. There are 3 feet in a yard. So you do 5 times 3 on the top first. That gives you 15, divided by the 0.914 on the bottom, and that gives you approximately 16.4 feet. So sometimes it's going to take a couple of different conversions because there's going to be more than one thing to convert in your units. That's especially the case when you're converting rates. So when converting rates, you'll need to not only convert just one measurement, but also both measurements that are part of the rate. When working with a rate such as 50 miles per hour, you might need to know the rate in different units such as meters per second. So you're not only going to have to convert the miles into meters, but you're also going to have to convert the hours into seconds. So let's do a few examples of this. Let's start with converting 2 miles per hour to feet per minute. So in this case, we are going to start with our 2 miles per hour, miles on the top, hours on the bottom. And then we're going to convert our miles into feet, starting off by using conversion of miles to yards, and then the conversion of yards to feet. So you'll notice with these 3 items that we have so far, we have a miles on the top and the bottom, so they'll cancel, and we have a yards on the top and the bottom, so they'll cancel as well, leaving us with feet on the top in place of the miles. Now we need to convert hours into minutes. So we're going to use a conversion that 60 minutes is an hour. Hours are going to go on top so we can cancel it with the one that's already there on the bottom. So all the units cancel except for our feet and our minute. Feet on top, minutes on bottom. We have our correct units of feet per minute. So you're going to multiply everything on the top, multiply everything on the bottom, and then divide the two. And when you do, you get 176 feet per minute. Now in example 8, the average traveling speed of a car on a road trip is 65 miles per hour. Express the speed in kilometers per hour. So here, we don't have to worry about converting hours, but we do have to convert kilometers. So we've got 65 miles per hour. We use our conversion factor, putting miles on the bottom so it will cancel. And then we multiply across the top and get approximately 104.6 kilometers per hour. And I encourage you to take a look at a car speedometer on this one. Look at the 65 miles per hour on your car speedometer, and then go to the smaller numbers on the inside of your speedometer and look and see approximately what that value is. It should come out to around 105, like we got here in this example. In example 9, the Waccamaw River rose 4 inches every 30 minutes after Hurricane Victoria. Express this rate in feet per day. So we're going to start with 4 inches every 30 minutes. Okay, so 4 inches on the top and a 30-minute time frame on the bottom. Then we are going to use our conversion factor to go from inches to feet. Inches go on the bottom on the conversion factor, so our inches will cancel off the top and bottom. And then we're going to convert our minutes into days, starting off with 60 minutes in an hour, and then 24 hours in a day. Cancel out all your units. You're left with feet per day, and multiply your numbers on the top, multiply your numbers on the bottom, and then divide what you have on the top and the bottom, and it should come out to a nice even 16 feet per day. The last thing I want to cover in this section is converting areas, because they take a little bit of a special thing to do as well. So let's start off by talking about conversion factors for area. When converting areas, the conversion factor must be squared because the area is expressed in square units, okay? Think about the size of a room. Talk about the size of a room being, say, 8 square feet. That's the area of the floor space. Or that might be a little bit small, but you get the idea, okay? So since we are talking about square units, we're going to have to square our conversion factors. And you'll see that in these two examples. Let's start with example 10. Convert 4.4 square feet to square inches. So we've got 4.4 feet squared, that's square feet, and we want to convert it to square inches. So we go and find our conversion factor from feet to inches. There are 12 inches in a foot, but you have to square the entire conversion factor, okay? And when you square the entire conversion factor, you square everything. Your inches become square inches, your feet on the bottom become square feet, and your 12, the value, also has to be squared. So when we square everything, you end up with 144 square inches per square feet, because 12 times 12 is 144. Then you can do everything like we did before. We cancel out our square feet, you multiply your numbers on the top here, and you get 633.6 square inches. In example 11, we're going to convert 40 square inches to square feet. So we're going to go the other way here. 40 square inches, we need our conversion factor from inches to feet, 12 inches in a square, and 12 inches in a foot. We square everything in the conversion factor, just like we did before, and we cancel out our square inches, and we end up doing 40 divided by 144, and that gives us approximately 0.3 square feet. Thanks for checking out my video in the Foundations in Algebra series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.